All right, so here's an example that will help you with the 3-1 to 3-4 test over velocity and acceleration. First of all, you have to remember that we have three things we're really dealing with: position, velocity, acceleration. The derivative of position will give you velocity. The derivative of velocity will give you acceleration. Another word for derivative is slope, remember. So if you look at the slope of the position graph, you're really looking at velocity. Or if you look at the slope of the velocity graph, that's going to give you acceleration. So let's say we have some type of moving object. Let's say we have something moving up and down. It could be a squirrel going up and down a pole, or it could be a particle moving back and forth on a line, or a tiger pacing back and forth in a zoo. Anything that's moving. Okay, it could be the temperature going up and down outside. Let's say this is the position. S equals 3x squared minus 12x plus 1. I went ahead and graphed it. So this is what the graph looks like. I'm going to go ahead and sketch it right on the board here. It's like it has a y-intercept just above the x-axis. Something like that. And I'm going to assume that our time, x is going to be our time here. X is time. And let's assume it's in seconds. And let's say our position, which in this case is s, or y on the calculator, let's say the position is in meters. So the vertical axis is in meters, horizontal axis is in seconds. All right? Find the average velocity of the moving object between 0 and 2 seconds. So right now, I've already traced to the point 0,1. This is the point 0,1 right here. 0,1. Or I could write it like this. That's the point 0,1. So that means after 0 seconds, the object is 1 meter. Let's say we're doing this. Let's say we're doing it on a horizontal axis. Okay, horizontal line. Let's say a particle at 0 seconds is at the 1 meter mark, right there. Let's try to find the average velocity between 0 and 2 seconds. Let's see where it's at after 2 seconds. So I hit trace 2, enter. Trace 2, enter. Or I could just plug 2 into here. If I plug 2 into here, I get 12 minus 24, which is negative 12, plus 1 comes up to negative 11. Or you can see right here, the point 2, negative 11 is right here. So that's the point 2, negative 11. So this would be 2. If you come across here, this is negative 11. So there's my position graph. You can use your calculator. If you have your calculator available to you on the test, obviously you can just do what I just did, graph it. But if you don't, you can get your values pretty easy. If I want to know x is in seconds, I could just plug 0 in for x, and I would get 1 for s. Or I could plug 2 in for x, and I'd get negative 11 for s. Keep in mind that these numbers are in meters, these numbers are in seconds. I'm trying to find velocity. Velocity would be in meters per second. So what am I going to have to do to get this from meters and seconds into meters per second? Write this in here. This is seconds. And this is in meters. What am I going to do on the graph? I have position. I want velocity. What would I do? The derivative. The derivative would give me velocity, okay? But really, I don't even have to do derivative. I could just do the slope. If I just did the slope of the secant line between this point and that point, let's go ahead and do that. This should give me average velocity. And we really have to watch your labels closely, and they kind of give you a clue if you're doing it right or not. So if I do the change in position over the change in time, that should give me the change in meters over the change in seconds, meters per second. So if I do negative 11 minus 1 on the top, and I do 2 minus 0 on the bottom, I get negative 12 meters in 2 seconds. In other words, this particle dropped, on the graph, it dropped 12 meters in 2 seconds. In other words, what we're saying here is on this particle that's moving along a line, it was all the way out here at negative 11 after 2 seconds. So it moved from here to here. It moved a distance of a negative 12 meters in 2 seconds. That's an average, negative 12 divided by 2, of negative 6 meters per second. What I'm trying to point out is you don't have to have the velocity equation or the velocity graph to get average velocity. You can use the position graph to get the average velocity. Just get the slope of the secant line on the position graph. That'll give you average velocity. Now if you want the instantaneous velocity, yeah, then you're going to want to instantaneous velocity at 3. Let's say this is 3 here. That means I got to find the derivative or the slope of the tangent line at 3. For that, probably the easiest way to do is do the velocity equation, which would be, let's erase that here, 6x minus 12. Then plug in your 3 seconds, the velocity at 3 seconds. 6 times 3 minus 12, 18 minus 12, you get 6 meters per second. So if you have to get instantaneous velocity, I would suggest, yeah, use the velocity equation. The slope right here is 6 meters per second. But if you want average velocity, just use your good old slope formula from Algebra 1 and use the position equation. Okay, so that's something to kind of keep track of for tomorrow.